Alright, in this video we're going over the fundamental theorem of algebra. Our LEQ for this lesson is how do you use the fundamental theorem of algebra to solve polynomial equations with complex solutions? Your vocabulary. The fundamental theorem of algebra says if p of x is a polynomial of degree n is greater than or equal to 1, which means it has an x term in it, then p of x equals 0 has exactly n roots, including multiple and complex roots. To kind of put that a little simpler, it basically means your degree equals your number of roots. So if you have a 5th degree polynomial, then you have 5 roots. All right, that's basically all that says. All right, let's look at a problem where we actually use the fundamental theorem of algebra. So what are all the roots of x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 equals 0? Well, we know we have 5 roots. All right, that's a given. We know we have 5 different roots. All right, so let's do some synthetic division, but first let's figure out what our roots can possibly be using the rational root theorem. We know this is p, we know this is q, the 1 that's in front of the x to the 5th. So since q is 1 and this is all the factors of p over q, this is basically just all the factors of 4 because anything divided by 1 is itself. So this is plus or minus 1, 2, and 4. Those are all the possible rational roots. So let's start with those. Let's start with 1 and see if 1 works. So we have a 1, a negative 1, a negative 3, a 3, a negative 4, and a 4. All right, so 1, 1, that comes out to 0, 0, negative 3, negative 3, 0, 0, negative 4, negative 4, 0. Oh, look at there. So 1 works. So we know that x equals 1 is one of our roots. Now, what I would do here, do synthetic division using your answer here because we started with the 5th degree, which means this is a 4th degree polynomial. So it's still going to be difficult to factor. All right, let's try another number. Let's try 2 now. All right, so drop the 1. So 1 times 2 is 2. That's 2. That's 4. That's 1. That's 2. That's 2. That's 4. That's 0. Oh, look at there. 2 works. All right. Now, we started with a 5th. This is a 4th, which means this is a 3rd. So let's do synthetic division one more time. Let's try 2 work. Let's see if negative 2 works. All right, 1, negative 2, 0, 0, 1, negative 2, 0. Oh, looky there. Negative 2 worked as well. So we have 3 rational roots. And now we have this, which is now a 2nd degree polynomial. I'm going to write it up here. Remember, this is your x squared term. We have no x term, and this is your constant, so plus 1. So now we have to factor this guy. All right, we know we have to factor this guy. Now, if you were in class and you could see my special case chart, hopefully you've written it down by now. When you have x squared plus 1, this could technically be written as 1 squared because 1 squared is 1. So this is technically a squared plus b squared. All right, it's technically a squared plus b squared, and that factors into a plus bi and a minus bi. If you notice, we'll have 2 imaginary roots. So we're going to have 3 rationals for this problem, and then just 2 imaginaries. Okay, so since this factors into a plus bi and a minus bi, this is going to be a plus 1i. I'm sorry, x plus 1i. Where's my eraser? There we go. This is going to factor into x plus 1i and x minus 1i. So x plus I is, so then we're going to have negative I and positive I. All right, so basically, this is the same thing. If you notice, this is the same thing you've been doing. We used rational root theorem to find all of our possible rational roots. Then we used synthetic division, checking to see which of those possible roots give us actual roots. And then, once we got down to a second degree polynomial, we just simply factored it to find our two remaining roots. So really, fundamental theorem of algebra is what you've already been doing, except now the fundamental theorem of algebra tells you exactly how many roots you're going to have. All right, so the degree of your polynomial is how many roots you have. Like in this case, we have a fifth degree polynomial. So if you count over here, we have 1, 2, 3, 4, we have 5 roots. Okay, that's all the fundamental theorem of algebra says. Now, that's not to say that you're going to have complex solutions, which in this case we do. We have negative I and positive I, because both negative I and positive I are roots of this function as well. So it doesn't mean you won't have complex roots. It just tells you the number of roots you're going to have. And the number of roots you're going to have, to say it again, is equal to the degree of your polynomial. All right? So that's pretty much it for fundamental theorem of algebra. It's what you've already been doing. It's synthetic division. You all know how to do synthetic division. So it's just synthetic division. The only difference with this lesson is the fundamental theorem of algebra tells you the exact number of roots you're going to have. So that's what we have here. Okay. The fundamental theorem of algebra tells you the exact roots you're going to have. And remember, the degree of your polynomial is equal to your number of roots. And don't forget that the degree is the highest exponent. Okay, so fundamental theorem of algebra, to say it again, repetition always works. Your degree equals your number of roots. And don't forget that your degree is your highest exponent. That's pretty much it for fundamental theorem of algebra. Watch this as many times as you want to. Make sure you come to class tomorrow ready to work some problems. See you tomorrow.